today we are kind of going to look at the quadratic formula and number of roots and things like that. First, we're going to solve by completing the square this equation. Now, this is actually where the quadratic formula comes from, and you're not going to probably have to do this on a test or anything, but it is kind of interesting to see where the quadratic formula comes from. Now, the first thing we're going to do is divide by a. So we're going to divide every term by a. A little different than factoring the a value out, but it accomplishes the same thing, and it just helps us neaten the formula up at the end. So when I divide everything by a, I've put my brackets around my first two terms because now I don't have a value I need to factor out. So I've got now x squared plus b over a x plus c over a. My next thing I'm going to do is half that middle value and square it, and then add it and subtract it to the formula. So half of b over a is 1 half b over a, or b over 2a, and then when I square it, it becomes b squared over 4a squared, and I add and subtract that. Now I'm going to factor that trinomial and get my perfect square. So I've got my half, I've got x plus b over 2a squared plus c over a minus b squared over 4a squared. I'm going to move those other two terms over to the other side, and I'm going to get a common denominator for them. So the b squared over 4a becomes positive, the c over a becomes negative, and I need to multiply it by 4a to get a common denominator. Now I have 4a squared. When I have my 4a squared, I can put both of those terms together. So putting both of those terms together, it's going to look like that. And I'm also going to bring over my square root. So it's plus or minus that square root value. Finally, we bring over the negative b over 2a. And now I have a common denominator again. So I can just make it into my quadratic formula. That's actually where the quadratic formula comes from. That's exactly how we get the quadratic formula. All right. So now looking at these three equations, we're going to use the quadratic formula for all three of them. So I'm just going to write it nice and big at the top. So x equals negative b plus or minus the square root b squared minus 4ac over 2a. On a test, I would want you to write the quadratic formula maybe once just to show me the formula you're using. I know most of you know it and have no issues getting to it, but you should still be showing that at least one time just to show your formula. So the first one, we've got x equals 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 16 all square root over 2 times 1. So we're going to get negative 8, or sorry, not negative 8, we're going to get positive 8 plus or minus the square root of 64 minus 64 over 2. Now that 64 minus 64 is going to become 0, so this is going to become 8 over 2, which is just 4. So x equals 4. So in this case, we have 2 or 1 root. We have 2 identical roots or 1 root of 4. And it's all based around right here. Okay, that is the important part of this equation. Okay, so that's number 1. Now number 2, do over here. Again, we're using quadratic formula, so we've got x equals negative 5 plus or minus square root of 5 squared minus 4 times 1 times 14. You're going to just not be able to see the 14, but it's there. Over 2 times 1, which is just 2. So we get negative 5 plus or minus the square root of 25 minus 4 times 14, which is 56. So we get negative 31. Just let me make sure that all my signs are right, and they are. We can't take the square root of a negative number, so this is inadmissible or not possible. I would say inadmissible is probably more correct, but for what we're looking at, you just need to state that you can't go any further. And then finally, we've got 3x in the middle and 6, so this will be number 3. So we're going to have x equals negative 3 plus or minus the square root of, oh, am I doing this right? I think I missed a number. It's okay.
Mr. Khosrowshahian, please call extension 3025.
There's Mr. Dixon.
Mr. Khosrowshahian,
helping us out.
3025.
So again, looking at this one, actually, let's make this value, let's make this c value negative. Okay, so it's going to be a negative 6. So now we get 9 plus 24, so we get negative 3 plus or minus 9 plus 24 is 33 over 2. Okay? Looking at all of these equations, this one, the very first one, sorry, you can't see me, I say this one as though I'm there. This one has one real root, or two identical roots, however you want to say it. This one has none, because of that again. Positive number here, we have two real roots. Okay? So when you're looking at these, that's a big teller on what or how many roots there are. So looking at these, the quadratic formula, the underneath the square root is the most important part. This slide is useless because the discriminant, and we already talked about it, tells us the amount of roots for a quadratic equation without actually solving the whole thing. So really all you need to look for is the b squared minus 4ac. If that's asking you how many real roots there are. Or if you are unsure if you got a question right, you can quickly do that and it'll tell you how many roots there are. So use the discriminant to determine the nature of the roots for each equation. So for the first one, we're going to just do b squared minus 4ac, so we're going to get, so I'll write it out. So we're going to get 6 squared minus 4 times 9 times 1. The big thing is the signs on A and C. Okay, a lot of the times those will really determine, because if either of those are negative, it makes this part positive. If they're both negative, then it goes back to being negative. But if either of those are negative just by themselves, it makes it positive, and you're always going to have two real roots. So here we're going to get 36 minus 36 and 0. So we get one root, or two identical roots. Over here, we've got to multiply everything by x first and bring that 4 over. So we're going to get 3x squared minus 5x. And then the 4 is positive, so it becomes negative equals 4. And that's the c value I was talking about. I can tell by looking at this equation that this is going to be a positive answer at the end. So b squared is negative 5 squared minus 4 times 3 times negative 4. Two negatives make a positive. You don't even really need to solve this. So you get 25 plus 48. And that's positive. I could stop right there if I want and say 2 roots. Okay, because that is going to be a positive answer. Okay? So you would probably want to go to the finish, so you'd probably want to write 73 down just to state the answer, but that is what we're looking at there. Looking at a question like this, what values of k will make two different roots? So what we need to do is just put in that if I want two different real roots, my whole answer needs to be greater than 0. Okay, because that's when we get two real roots. So in this case, we're going to have negative k squared minus 4ac, sorry. So what do we have? 2 and 3. So negative k squared minus 4 is 8 is 24. Okay, so k then needs to be greater than, or k squared, because k, negative k or k are going to be the same thing, this value right here. So k squared needs to be greater than 24. So that means that k has to be greater than the square root of 24. Now, if it says find values, I've given you any value that really you could start at 5 and just pick any number, because 5 is going to be big enough. 5 squared is 25, 6 squared is 36. It just says find values. It doesn't say find the range or the domain or the inequality that's proving this. It just says it's got to be greater. Two equal roots. Well, that's going to be when this is equal to 0. So now, k equals the square root of 24. That's the only time that'll happen, because the square root of 24 is going to give us this whole thing here being 0. Okay, it's going to be 24, or the square root of 24 squared, and then it's going to go to 0. And no real roots, well, we've already solved it all. Now we just flip the sign. Less than the square root of 24. If you wanted to put in values, 3, 2, 1, and so on. Okay? The one thing you have to be careful with is when you get to negatives, so because a negative squared is going to give us that positive again. So if we got less than the square root of 20, or negative 24, the square root less than the negative square root of 24, so if I put a negative in front here, and then squared it, it's going to give us the same answer. But this, for all intents and purposes, is just asking us to find some examples. Once I find the positive numbers, I can just say for the first one, 5, 6, 7, 8. For the middle one, it has to be this, because that's the only way we can get 0. And for the last one, 1, 2, or 3 would be fine. And I'm going to give you a worksheet today from, well, so Tuesday and today's worksheet. Okay, so you won't need your textbooks. Worksheet. See you tomorrow.